Assalamualaikum warahmatullahi wabarakatuh. Today we will like to present about aromatic compound. Before that, let me introduce all my group member. First, Abdul Rahim bin Zulkifli. Second, Auni Anika binti Masli. Third, Rahil Sajijah binti Muhammad Khairun Nizam. Fourth, Shazwan bin Afrizal. And lastly, Muhammad Zain Zafran bin Zulkifli. أعوذ بالله من الشيطان الرجيم وأنفقوا في سبيل الله ولا تلقوا بأيديكم إلى التهلكة وأحسنوا إن الله يحب المحسنين. This verse recommends us not to deal with fluorobenzene since it is very dangerous to human.
So for question number 1A, draw the structural formula for each of the following. Number 1, para-bromotoluene. Para means that the substituent is attached at the carbon number 1 and carbon number 4, while toluene also means methylbenzene. So the other names of para-bromotoluene is 1-bromo-4-methylbenzene. So for the structural formula, the benzene ring at the carbon number 1, bromine will attach here and methyl will attach at the carbon number 4. Number 2, ortho-dibromobenzene. Ortho means that the substituent will attach at the carbon number 1 and carbon number 2. So the other names will be 1,2-dibromobenzene. For the structural formula, first bromine will attach to the carbon number 1 of the benzene ring, and the second bromine will attach to the carbon number 2.
Draw 3,5-dinitrophenol. First, we need to draw the phenol. Phenol is a phenyl group bonded to a hydroxy group. Then, add NO2 to the phenol at the carbon number 3 and number 5. So we get 3,5-dinitrophenol. For the question A4, draw benzyl bromide. So we just need to draw a benzene ring substituted with a bromomethyl group.
In order to synthesize 4-bromobenzoic acid from benzene, first benzene will undergo Fiedel-Crafts alkylation with the presence of FeBr3 and CH3Br. The product form will be toluene. Then toluene will undergo halogenation with Br2 and FeBr3. The product form will be a mixture of ortho and para as major product. Then the 4-bromotoluene will undergo oxidation with hot alkaline potassium permanganate to produce 4-bromobenzoic acid.
For question B number 2, we must outline the synthesis from ethylbenzene to 4-bromophenylethyne. So there are 3 steps. We want to change the side change of benzene, which is ethyl, to ethene. In order to do that, first we must change the alkyl group to alkyl halides, because later we want to synthesize alkenes by the hydrohalogenation of alkyl halides. So, first step, ethylbenzene will undergo halogenation by using free radical substitution reaction. Ethylbenzene reacts with bromine gas in the presence of UV. Bromine atom substitutes the hydrogen atom in the ethyl group, give 1-bromo-1-phenylethane, where the bromine atom attached at the secondary carbon of the ethyl. Thus, it is the major product. And the minor is 1-bromo-2-phenylethane. Second step is dehydrohalogenation of 1-bromo-1-phenylethane. 1-bromo-1-phenylethane reacts with potassium hydroxide dissolved in alcohol, will give phenylethane as a main product and hydrogen bromide as side product. Halogenation of phenylethane using electrophilic substitution whereby bromine atom will attach as a new side change for benzene in ortho-para direction. So, phenyl ethene will react with bromine gas in the presence of iron 3 bromide as a catalyst give 4-bromophenyl ethene and 2-bromophenyl ethene as the product. So, these are the steps to obtain 4-bromophenyl ethene from ethyl benzene.